Hello everyone, let me introduce myself. My name is Ammar Firdaus bin HISYAM, matrix number 223665, and I am the leader of Group 1. In this video, we will present about graph theory, where we will explain about 5 subtopics in graph theory. Before we start presenting, I'm going to introduce each of our group members and which topic will they be presenting. The first one is Muhammad Naim, matrix number 224234. He will present about graph models. Next is myself, Ammar Firdaus 223665, and I will present about isomorphisms of graphs. The third one is AMIRUL HAKIMI 223734. He will present about edge counting. The fourth one is IMAN 223285. He will present about planar graphs. Lastly, FATHUL Islam 224756, and he will present about applications of graph. So, let's begin our presentation about graph theory.
My name is Muhammad Naim bin MAZNI. My number matrix is 224234. Today, I will present about graph models. What is graph models? Graph models are mathematical representations that use graph theory to describe relationships and connections between entities. In graph theory, a graph consists of nodes known as vertices and edges, where nodes represent entities and edges represent relationships or connections between those entities. Graph models provide a visual and conceptual framework for analyzing and understanding the structure of relationships within a system. First, null graph. A null graph has no edges. The null graph of n vertices is denoted by n. The second one, simple graph. A graph is called simple graph or straight graph if the graph is undirected and does not contain any loops or multiple edges. The third one is multigraph. If in a graph multiple edges between the same set of vertices are allowed, it is called multigraph. In other words, it is a graph having at least one loop or multiple edges. The fourth one is directed and undirected graph. A graph G equals in bracket VE is called a directed graph if the edge set is made of ordered vertex pair, and a graph is called undirected if the edge set is made of unordered vertex pair. The fifth one, connected and disconnected graph. A graph is connected if any two vertices of the graph are connected by a path, while a graph is disconnected if at least two vertices of the graph are not connected by a path. If a graph G is disconnected, then every maximal connected subgraph of G is called a connected component of the graph G. The sixth one is regular graph. A graph is regular if all the vertices of the graph have the same degree. In a regular graph G of degree R, the degree of each vertex of G is R. The seventh one is complete graph. A graph is called complete graph if every two vertices pairs are joined by exactly one edge. The complete graph with n vertices is denoted by Kn. The eighth one is cycle graph. If a graph consists of a single cycle, it is called cycle graph. The cycle graph with n vertices is denoted by Cn. Ninth, bipartite graph. If the vertex set of a graph G can be split into two disjoint sets, V1 and V2, in such a way that each edge in the graph joins a vertex in V1 to a vertex in V2, and there are no edges in G that connects two vertices in V1 or two vertices in V2, then the graph G is called a bipartite graph. 10th, complete bipartite graph. A complete bipartite graph is a bipartite graph in which each vertex in the first set is joined to every single vertex in the second set. The complete bipartite graph is denoted by Kxy, where the graph G contains x vertices in the first set and y vertices in the second set.
Now, I will be presenting about isomorphisms of graph. So, what is isomorphism of graph? Let's take a look at the situation here. Let G1 and G2 be graph with vertex set VG1 and VG2 and edge sets EG1 and EG2. G1 is isomorphic to G2 if and only if there exists one-to-one correspondence, such as this function G and this function H, that preserve the H endpoint functions of G1 and G2 in the sense that for each vertices is an element of VG1 and each edges is an element of EG1. Okay, two graphs are said to be isomorphic if they have same number of vertices, same number of edges, and equal number of vertices with a given degree. Let's take a look at an example here. There are two graphs that are different, but they look kind of similar. So, based on these two graphs, how can we know that it is isomorphic? So, the first way is to look at the number of vertices, number of edges, and number of given degree to see whether they are the same or not. So, from this graph, we can see that they have the same number of vertices, which is 4. As you can see as the G1, you can see the A, B, C, D, which is the vertices of graph 1. And for the graph 2, they have W, X, Y, Z. For the number of edges, you can see that both of these graphs have the same number of edges, which is 4. As you can see from graph 1 and graph 2, for the number of degree, you need to look at each of the vertices to see whether they have the same degree or not. From the graph 1, you can see that there are 1 vertices that is connected with 3 edge, and then 1 vertices that connect with 1 edge, and 2 vertices that connected with 2 edges. Same goes with the graph G2. So, from this, we can say that they have the same number of vertices with a given degree. Another way is we can also define it by using function to see whether the function is one-to-one function. In this example, we can see the function g to show that whether the vertices from graph 1 is one-to-one with the vertices from graph 2. Next, we can also use the edges to see whether they have the similar edge endpoint from the graph G1 to the graph G2. So, when we have all this information, we can conclude that G1 and G2 are isomorphic. So, that's all for the isomorphism of graph.
Assalamualaikum. My name is AMIRUL HAKIMI bin ROSAZLAN and my metric number is 223734. And now I am going to present about edge counting. So firstly, before we want to count how many edges are in our graph, we need to understand what the definition of a graph of an edge is. So, based on this definition, an edge is one of the connections between the nodes or vertices of the network. So, for example, if we have a vertex of A, B, C, and D, and they are all connected like this. Okay, so an edge is the connections between the nodes or vertices. So it means that the edge is here, the connection between A and B. Okay, so if we want to count it in based on this graph, there should be 1, 2, 3, 4, and 5 edges in this graph. Okay, another example, if we have A, B, C, D as the vertices and the graph looks like this. Okay, so what I draw here is a loop. So the loop is also counted as one edge. Okay, so in this example, the total number of edges should be 1, 2, 3, and 4. That's all from me. Thank you.
Okay, my name is IMAN bin MOHYIDDIN. My matrix number is 223285, and I will explain about planar graph. So, planar graph is a type of graph that can be drawn on a flat surface without any of its edges crossing each other. It means whenever we do a graph, directed graph, there is no edges that will intercept except at the vertex only. So the figure on the right side is an example of planar graph. So that's all from me. Thank you.
The applications of the graph. In many fields, quantitative discipline is crucial. Graphs are regarded as an excellent modeling instrument that can be used to simulate various phases of relationships between all physical circumstances. Graphs are a useful tool for illustrating a variety of real-world issues. So, I will show some application of graph, which is social networks, transportation networks, and infectious disease. Okay, first, social networks. The graph helps you to visualize the relationship between the selected vertex and all vertices that the selected vertex is linked to. Using this graph, you get another way to see who follows who on Instagram. So the vertices represent the individuals and the edges represent the relationships between them. This is a directed graph which describes who follows who on Instagram. For instance, George is following Dennis on Instagram, but Dennis is not following George. On the other hand, Esther and Claire are following each other on Instagram. So from this graph, we can know who follow who on Instagram. Next, the transportation networks. A transportation network is a network or graph in geographic space describing a station that permits movement of flow. For example, this graph shows the transportation network of the road. So this graph is used to show people a map or a way to go to their destination. This graph is a weighted and directed graph that can show which is the shortest distance to the destination. This graph really helps to plan a journey with the shortest distance. For example, from C4 to C2, you can choose the shortest distance, which is C4, C5 to C2, rather than C4, C1, C2, which is more longer than C4, C5, C2. So this graph helps to plan a journey with the shortest distance. Next, the infectious disease. This graph helps to visualize the spread of an infectious disease in an area. For example, the spreading of COVID-19 around the world. This graph helps us to know the starting point of the disease and area that have been spread widely. The vertices represent the airports because mostly their spreading is done by travelers from another country. This helps us to prevent the spreading of infectious disease in our area. So that's all for the application of graph. Thank you from our group.